This Delhi question came to my mind yesterday. What if the 1.35 billion cubic kilometers of water in Earth's ocean suddenly vanished? Well, the first thing you will notice... Actually, wait. You probably die before you even had the chance to notice everything. If the 1.35 billion cubic kilometers of water in Earth's ocean suddenly vanished, the first thing you will notice before the total collapse of global shipping industry is that the planet has lost its thermostat. The ocean currently absorbs over 90% of the excess energy trapped by greenhouse gases. Water has a high specific heat capacity of 4000 joule per kg. Dry sand by comparison has a specific heat of just 800 joule per kg. Without the water to act as a heat sink, the average surface temperature will jump from 15 degrees Celsius to 50 degrees Celsius. In equatorial regions, you will expect temperatures to regularly exceed 100 degrees Celsius. Removing the weight of the oceans, roughly 1.35 into 10 to the power 21 kg, will trigger a massive vertical movement of the Earth crust called isostatic rebound. The ocean basins, no longer weighed down, will begin to rise to find a new equilibrium. We can calculate the theoretical uplift using this relationship R equal to d naught into rho w upon rho m. Given an average ocean depth d naught of 3.7 km, a water density rho w of 1000 kg per meter cube, and a mantle density rho m of 3300 kg per meter cube, the ocean floor will eventually rise by about 1.12 kilometers. While some of this responses is immediate, the viscous flow of the mantle beneath the rising basins will take 10,000 to 100,000 years, causing constant planet-wide earthquakes. The disaster then move into the Earth interior. Plate tectonics, the movement of Earth crust, is actually dependent on water in a process called hydrolytic weakening. Trace amount of water within the crystal lattice of mantle minerals reduce the mechanical strength of the rock. This allows the lithosphere to bend and slide back into the mantle at subduction zones. Without the oceans to replenish this water, the mantle would eventually outgas its remaining moisture through volcanoes. As the mantle dries out, its viscosity will increase by over 2 orders of magnitude. This will cause plate tectonic to grind to a halt, transitioning Earth from a stagnant lid regime like Mars or Venus. Without subduction to act as a geological sink, volcanic CO2 will build up into the environment indefinitely, triggering a runaway greenhouse effect. If the oceans were vaporized rather than simply deleted, the atmosphere will become a high-pressure nightmare. The mass of the oceans is about 275 times greater than the mass of our current atmosphere. Turning that entire mass into vapor will raise the atmospheric pressure at the former sea level to between 200 and 230 atmospheres. To keep all that water in the gaseous state, the global temperature will need to stay around 350 degrees Celsius. Eventually, solar ultraviolet radiation will break the water molecules apart in the upper atmosphere through photodissociation. The light hydrogen atom will reach escape velocity and vanish into space, while the heavier oxygen atom will remain behind to oxidize the surface. Over hundreds of millions of years, Earth will lose all its hydrogen, leaving a CO2-rich rock hot enough to melt lead. Biologically, the situation is terminal. The ocean houses 95% of the planet biosphere and provide half of the world's oxygen via marine phytoplankton. The loss of this organism will cause atmospheric CO2 to spike by 200 parts per million almost instantly. Humanity will be forced into deep underground habitats to escape surface heat or into polar refugia to try and find remnant ice.